More on cost curves today. So we, at this point, know how to do our calculations, right? So at this point, you understand that I'm going to give you quantity and total cost, right? I have to give you those two pieces of information. And everyone's clear that from that, you're going to be able to find variable cost, marginal cost, average total cost, average variable cost, and average fixed cost, right? But everyone's clear that you can't do anything unless I give you quantity and total cost of the operation, right? But once I give you that, you can find all of those pieces of cost information. And do you agree with me, guys, that these are pretty easy cost calculations, right? You might make a careless error, but remember, I've given you two ways to check your work. So remember, check your work using equation 1. And you know with equation 1, total cost has to equal fixed cost plus variable cost. So if I give you a chart and that doesn't hold, you've made some careless error, right? So this is important that you check your work and you make sure that you've not made any mistakes. And then the second thing is that we know average total cost equals average fixed cost plus average variable cost. So that's a second way to check your work, right? So I don't have a way for you to check marginal cost, but this is going to allow you to make sure you've not made any errors on just 90% of the calculations you do on the chart. So you really want to do that. Now, if you graphed this information correctly, you should get something that looks like this. Now, I want to warn you, you only had, what, 10 data points or something like that? And so yours might be less smooth, but imagine if instead of 10 data points, I had given you 30 data points, 50 data points, right? It would smooth out, right? So if yours looked a little jaggedy, no worries. That's because you only had 10 or whatever data points. So you're going to get something that looks like this. So I want everybody to draw a good sized graph in their notebook because we're going to be adding on 3 curves. The first curve that I asked you to draw was marginal cost. And so you got something that kind of looked like that. It was hook shaped. So marginal cost. All right. The second curve that I asked you to draw was average variable cost. Now, don't draw yours yet because there's a couple things that I need to show you. First of all, it's a U-shaped curve, but I can't just put it anywhere. There's a mathematical relationship that tells me I know it's going to look like this. It's going to be U-shaped. At its bottom, it's going to intersect. It's not very pretty. Let me do that better. At its minimum, it's going to intersect with marginal cost. All right. So draw your average variable cost, but pay particular attention to the point of intersection. They have to intersect just like mine did. It's not a coincidence. There's a mathematical property that we're going to talk about that explains why those intersect where they do. Now I'm going to add the next curve I asked you to draw, which was average total cost. And there are 2 things that we need to observe about average total cost. So do not draw it yet. First thing, we have to draw it U-shaped. Actually, there's 3 things. I have to have my intersection in the right place. And they have to get closer together. So hold on, don't draw it yet. Make sure it's U-shaped. Make sure it intersects marginal cost at its minimum. And hold on, make sure that they get closer and closer together over quantity. All right? So you've got to draw it very carefully, closer and closer together over quantity. So guys, from this graph, we observe a few things. So let's list our observations. Our first observation here is that all 3 curves are what I'm going to call U-shaped. All three curves are U-shaped. Now, marginal cost is more kind of like a fish hook, right? But it's still U-shaped. And by U-shaped, I mean goes down and then back up. So all three of these curves are U-shaped, right? Second thing that we observe is that marginal cost intersects at the minimum of average variable cost and average total cost, right? So we see that marginal cost cuts through the minimums. And again, that's not a coincidence. There's a mathematical property. So let's make a little note. Kind of there's a mathematical explanation. And we'll go through that. The third thing that we see, guys, is that average total cost and average variable cost get closer and closer as Q gets bigger. So as quantity increases, we see that those curves get closer and closer and closer, but we want to be careful to understand that they will never technically cross or touch. And they're not going to cross. So average variable cost is never going to go up above average total cost, because that would make no sense, right? All right. So we're going to spend the first part of this lecture understanding kind of why it looks the way that it does. Now, you're going to have to wait on number one. Why does number one hold? Why are they U-shaped? It's related to productivity. So our next topic after cost, we'll cover this. So we're going to have to kind of defer number one. All right. Let's talk about number three, because it's a little bit easier. Let's talk about number three. Why do those curves get closer and closer together? So why do average total cost and average variable cost get closer and closer together as Q gets bigger? So let's answer that question, because that's a pretty easy question to answer. To answer that question, guys, let's look at equation 6. What does equation 6 tell us? Flip back to your notes. What does equation 6 tell us? Okay. Average total cost equals average variable cost plus average fixed cost. All right. So let's start with equation 6. Start with equation 6. All right. And now let's rearrange it a little bit. So I'm going to rearrange. And let's look at the difference between average total cost, right? I want to get the distance between. In other words, this right here. I want to calculate this height right here. So if I want to calculate that height, do you agree that I need average total cost minus average variable cost, right? The difference between the two. Everyone agree? So if I want to capture that purple distance between the two curves, I take the top one minus the bottom one. Well, according to my equation, what's that going to be equal to? Average fixed cost. Good. So the distance between those two curves is average fixed cost at that level of Q. And this is average fixed cost. If I go further, average fixed cost at a different level of Q. So the difference between the two curves is average fixed cost. So we didn't need to graph average fixed cost. I didn't ask you to graph it. And the reason I didn't ask you to graph it is because we already have a way to measure it, right? We have a way to measure it. But I still haven't answered the question. So we know the difference between the two is average fixed cost. We understand that now we can measure average fixed cost on the graph, but we haven't really explained why they get closer and closer together. So let's take a deeper look at average fixed cost. So let's go back and review average fixed cost. So average fixed cost, if I want to calculate average fixed cost, how do I do it? How do I calculate average fixed cost, everyone? Guys, put your phones away. Fixed cost divided by quantity. Good. All right. Now, let's add some numbers just to make it easy. Let's let fixed cost be 1,000. And let's graph it. And I want to graph average fixed cost. So fixed cost is 1,000. So guys, when output is 1, what is average fixed cost? Everybody, what is it? It's going to be 1,000. But what about when output is 2? Everyone agree it's going to be 500? And what about when output is 4? We'll skip 3. Output is 4. What's it going to be? 1,000 divided by 4 is what? 250, right? So guys, what's happening to average fixed cost? It's getting smaller and smaller and smaller, right? Does everyone agree? If average fixed cost is fixed cost over Q, then do you agree with me that as quantity gets bigger, that denominator gets bigger, right? So 1,000 divided by 1, 1,000 divided by 2, 1,000 divided by 5, 1,000 divided by 10, 1,000 divided by 20, 1,000 divided by 1,000. All right, it's continuously getting smaller and smaller. So as quantity increases, average fixed cost gets smaller and smaller. Right? So if the difference between average variable cost and average total cost, it's not a beautiful graph, but if this is average fixed cost, then they have to get closer and closer together. Does that make sense? So it's a pretty easy explanation for why the graph had to look like that, right? Now I might, if I stretch it out this way, it might be more gradual if I make my graph kind of wider, right? But everybody with me? So going back to this, we have explained 3. We've said we're going to defer on 1. So the only thing left we need to explain is why is it that marginal cost intersects at its minimums? Guys, put your phones away. So why does marginal cost intersect at its minimum? So let's answer that question, number 2. All right. So question number 2, why does marginal cost cut through the minimum of average total cost and average variable cost? Let's answer that question. And so guys, I want to convince you, you already understand this. Because if I gave you a different kind of an example and it wasn't cost, you could rock on it. So in a minute, we're going to do an example that's familiar to you, but I want to convince you that there is a unique relationship between any average variable and its corresponding marginal. There's a unique relationship between any average variable, doesn't have to be economics, and its corresponding marginal component. I'm going to show you that. So just get this down, and then I'm going to convince you that this is true. And to convince you, we're going to use GPA, because you understand GPA. And there is an average component So a way of looking at it as an average, and this is going to be your overall GPA. And I'm talking about for your career. So if you've been at Longwood 4 semesters, then your overall GPA for 4 semesters. So then what is your marginal? What is the marginal? What was that? Somebody said it, I think? A semester, exactly. So the marginal component is this semester. So for our GPAs, we have an overall average and we have a marginal. And do you agree that the marginal feeds into the average? Right? Each semester, you finish the semester, the marginal feeds into your average and it changes your average, right? So the marginal feeds into your average and it makes your average GPA go up or down, or could stay the same, right? But you understand? So this is same as batting averages. If you have a great game, that's your marginal, right? Your batting average is the average. Guys, put your phones away. It's always the same people. Please put your phone away and pay attention. So guys, batting averages. Do you agree you have a good game? And it can make your batting average go up. You have a bad game and it makes your batting average go down, right? So it's really simple. So there are 3 cases, right? There are only 3 cases here. And those cases are that your marginal is greater than your average. So what would that mean? This semester is greater than your overall, right? So this semester you get a 3.0, but your overall average had been a 2.8. So what happens to your average? Which way does it go? Everyone agree that your average is going to go up, right? And second, if your marginal is less than your average, so let's say you have a 3.0 this semester, but your average is a 3.4. So this semester you get a 3.0, but your overall average was a 3.4. What happens to your average? Goes down, right? Your average goes down. And what's the last case? They are the same. And occasionally that happens. So you have a 2.9 this semester, and your overall was a 2.9. So what happens to your average? Stays the same. So guys, if you understand it for GPA, then you understand it for cost. They work exactly the same. Now, we still haven't exactly answered why they intersect. So we have one kind of more step to think about. But is everyone with me to this point, right? This is very intuitive. You get this. So the last thing we have to think about is this case right here, where they're equal, right? So let's think about this scenario. Marginal feeds into the average. So scenario 3, we're saying the marginal feeds into the average, but it doesn't pull the average up or down, right? So scenario 3, we're saying that the marginal is feeding into the average. Semester's over, we're updating your overall GPA, but your average does not go up and it does not go down. What's the only way that can happen? It only can happen if what? They're equal, right? So this can only happen if they are equal. Well, where are two curves equal? When they what? Intersect. Good. So they're only equal where they intersect. You with me? So that's how we know if they're equal. If your GPA is a 3.0 and your overall is a 3.0, your GPA can't be going up or down. And it works the same with cost. So let's take a look at cost. All right, did everyone get that? Sorry. Everyone get that? All right. So let's go back to our cost curves. We've got marginal cost. We've got average variable cost. And average total cost. And remind me again, where's average fixed cost? Yeah, in between. The distances between are average fixed cost. So I don't need to draw average fixed cost. I've already got it, right? Although some professors have you plot it, but it's really redundant. Okay, so let's look at output Q0. Output Q0. At Q0, what do we see? We see that what's greater, the average or the marginal? Let's just look at average total cost. Which is greater, average total cost or marginal cost? Guys, at Q0, which is bigger? Well, how would I read it? Remember what's on the axes. So if I'm trying to read, I'm measuring the height, right? So which is bigger, average total cost or marginal cost? Yeah, does everyone agree? Average total cost is greater than marginal cost, right? Everyone agree with that? So based on what we just learned about GPA, if the average is greater than marginal, then that means what? The marginal is what? Less than the average, right? Marginal is less than the average. So that's maybe the easier way for us to think about it. Marginal is feeding into the average. If the marginal is less than the average, then which way should the average be pulled? If your marginal is less than your average, then, right, if this semester is less than your overall GPA, it pulls your GPA what? Down. All we're doing is looking at costs. If my marginal cost of production is 8, but my average cost of production is 10, My marginal's feeding to my average, and it's pulling my average cost which way? Everybody, average total cost has to be what? Going down. Is that what we see? Is that what we see here? Do we see average total cost going down? Yeah, look at the green arrow, right? Average total cost is being pulled down. All right, let's draw our graph again. And some of you, I think, are having a little trouble seeing it, so I'm just going to put in the average total cost. Maybe that will help. All right, so let's look at output Q1. And remember, dollars on the vertical axis. So measuring heights, right? Measuring heights. So at output Q1, what do we see? Which is greater? Which is greater, guys? Marginal cost or average cost? Everyone agree marginal cost is greater? Okay. So marginal cost is greater than average total cost. Okay. I'll give you a second to catch up with me. All right, so if marginal cost is greater than average total cost, which way does the average get pulled? So if this is $8 marginal cost to produce the last unit, but my average cost had been $6.50, which way is my average total cost getting pulled? Everybody agree? Up. Is that what's happening on our graph? Yeah, look at the green arrow. We see that marginal's feeding into the average and it's pulling the average up, right? So there's a unique relationship. Obviously then, if we're at Q2, what's the situation? Marginal cost is what compared to average total cost? The same, so they're equal, right? So that's like your GPA being a 3.0, and this semester you get a 3.0. So what's happening to my average? Yeah, it stays the same. So I have to be at a point where we're not going up or down. Is that the case? I'm at a point where we're not going up or down, right? This can only happen at the minimum of a curve. So that can only happen at the minimum. It's the only way that takes place. Does that make sense to everybody? So we have to be precise in how we draw our graphs. We have to be precise in how we draw our graphs. You can't be careless, or else you're really violating the underlying mathematical principles. And it has nothing to do with economics. It's just the relationship between anything average and anything marginal. So what if I drew it wrong? Let's take a look. Let's say I drew it kind of askew. Let's look at what we would be saying, and it would be nonsensical. Okay? So what if I drew it by accident like this? So I'm going to make a note so somebody doesn't think I'm doing this for real. So here's my accident. I come in here and I put my marginal cost, and I'm careless, so I come in here. Ooh, that's not even exaggerated enough. Let's do it more exaggerated. I come in here and I put my average total cost like that. Okay. If I put in my average total cost like that, well, let's take a look at the point of intersection. So at Q0, what do we see? We see marginal cost equal to average total cost, right? But what's happening to average total cost? It's decreasing, right? Average total cost is decreasing. Is that possible? Can they be equal? Can you have a 3.0 this semester and a 3.0 overall, but then your GPA goes down? No, it's mathematically impossible. So we don't want to make careless errors. Okay? Impossible. Everybody with me? All right. So do you feel pretty comfortable with the cost curve graph? I mean, it takes a little time to kind of get the hang of drawing it quickly, precisely, and correctly. But you basically understand why it looks the way it does, other than the fact that we don't really know yet why they're U-shaped. And we'll learn that in another couple days. All right, let's add on then. All right. Okay. So we want to realize that from a cost curve graph, we can find 7 pieces of cost information. From one cost curve graph, we can find 7 pieces of cost information. And all we did was draw 3 curves. So that's kind of cool. This graph is really going to be able to tell us everything that we need to know about the cost structure of firms. So that chart that we did, all of that stuff in the chart gets captured in the graph. So we can find marginal cost. We can find average total cost. We can find average variable cost. And we can find average fixed costs. Those are the first 4. And we need to lump those first 4 things together because those are easy. All we have to do is read heights of the cost curves. So all 4 of those things come from just reading the heights of the costs. So we have a marginal cost curve, right? We have an average total cost curve. We have an average variable cost curve. And then where do I get average fixed cost again? Distance between the 2, right? So those are pretty easy. But we can also find total cost, not average total cost, but total cost. We can find variable cost, and we can find fixed cost. But 5, 6, and 7 are a little bit more challenging to observe on the graph because these are going to be represented as areas on the graph. These are going to be represented as areas on the graph. And by an area, I mean it's going to be some kind of shape, rectangle-ish, all right? But once we get the hang of it, it's pretty easy. But what that does mean is that we're going to have to be able to put a lot on one graph. So I've asked many, many times to bring in your colored pens, and I think it's going to get harder and harder and harder to take notes without them. So if you still haven't brought any in, I would urge you to do so because it's going to be very difficult for you to follow your own notes. Okay? All right, well, let's do an example. Let's do an example. So let's draw a pretty good sized cost curve. All right. So my hook-shaped marginal cost, my U-shaped average variable cost, it gets cut by marginal cost at its minimum. Oops, it's ugly. And my average total cost. All right. So get your graph ready. And I'm going to just randomly pick an output level. Okay? I'm going to randomly pick an output level. Now, I'm not saying at this point that that's where the firm wants to be. We don't really know at this point, okay? So I'm not trying to say this is the optimal place to be. We're just going to take a look. Now, once we pick an output level, we look straight up. So let's draw a dotted line. So once you pick an output level, you're just reading the heights of the curves straight up. So if I want to get marginal cost, I go straight up to point A. But guys, is A my marginal cost? On a test, would that be an answer? Where do I measure costs on this graph? On the what? In between the heights? No. So let me ask that a different way. Which of my two axes measures dollar figures? Which one? My vertical axis. Does point A in the middle of the graph, is that a dollar figure? No, that's a Cartesian coordinate, right? So where do I go to get the dollars? I have to come over to the axis. So marginal cost. I've got to measure it on the vertical axis. So this height right here is marginal cost. Well, now let's look at average variable cost. I need to go up to point B and measure this height. But again, B is not a dollar figure, it's a Cartesian coordinate. To measure the dollars, I have to come over here to the axis. So here's average variable cost, right? If I want to measure average total cost, I've got to go all the way up to point C. Oops. But again, measuring it over here on the vertical axis. So then how am I going to measure average fixed cost? Average fixed cost, how do we measure it? Average fixed cost is going to be this distance right here, but measured on the vertical axis, it's going to be the difference between average total cost and average variable cost, right? So, again, for marginal cost, average variable cost, average total cost, and average fixed cost, I'm simply reading heights on the cost curve graph. So I'm just reading heights. All right. Now, that's easy. Everybody with me? That's easy. And I could give you dollar figures. For example, maybe marginal cost is 3, and maybe average total cost is 12, and maybe average variable cost is 6, which would tell me average fixed cost is what? What would average fixed cost be? Everybody, what would it be? 6, right? What equation did I use to figure that out? Equation 6, right? Okay. So you might have to read points, or you might have to read numbers. So I could call this F dollars, I could call this G dollars, I could call this K dollars, right? You have to get comfortable with both. Everybody with me? All right. So now let's talk about the other 3 because they are a little bit harder. Okay? Let's talk about how to find total cost on the graph. Now we want to remember on the graph we have average total cost, right? We have average total cost. But I want to find total cost, right? So let's start with what we have. So I've got average total cost, which we know is total cost divided by Q. Can I solve for total cost? Can I solve for total cost, guys? Sure. So let's solve for total cost. Total cost would be equal to what? What would total cost be equal to here, guys? Average total cost times quantity, right? And that makes sense. On average, my total cost multiplied by my quantity gives me back total cost, right? So it needs to be easy for you to kind of see these connections here, okay? So we're looking for a box. And that box is going to represent total cost. And it's going to have a height and a length. So the length is going to be a quantity. And the height is going to be average total cost, right? Because when I multiply height times length, right, I get the area of a box, right? So this is what you're familiar with from high school. Height times length equals the area of a rectangle or square. Everybody with me? So we're just going to use some of our very, very basic math tools. Now let's look at it graphically. So our marginal cost curve. We've got an average total cost curve. Not going to put everything else in. Let's let output be Q0. So everyone make sure you've drawn your graph. Once we pick an output, remember we just go straight up, find the relevant point on total cost. So we agree that this is average total cost. Do we have a box with a height of average total cost and a length of Q? Yeah. So here's our height. Here's our length. Does everyone agree that I've gotten back a box? So this box right here represents total cost. Not difficult, right? Now remember, there may be another curve in there. Let me throw it in here. Let's say there's a average variable cost that looks like that, right? Doesn't matter. It's not relevant. Everyone agree? Not relevant. All right. So let's make a note that we're going to find variable cost the same exact way. Right? We've got average variable cost equals variable cost divided by Q. Which means variable cost equals average variable cost times Q. So we're looking for a box that's going to be variable cost, and it's going to have a height of average variable cost and a length of Q. Right? So I don't even need to do that because you would know how to do it. Could you find it on this graph here? Would you be able to find it? Yeah. We start at Q0, we go up to average variable cost, right? And over, here's average variable cost. So now I have a height and I have a length, giving me back that purple box, right? Easy. Okay. Everybody with me? So let's do the last one really quick, because this one throws people off a little bit. We need to find fixed cost. Find fixed cost. So same thing, remember, we have average fixed cost. Where is average fixed cost on the graph? Where is it again? The distance between average total cost and average variable cost, right? So we have those two. So if average fixed cost equals fixed cost divided by Q, I can rearrange to get fixed cost equals average fixed cost multiplied by Q, right? Everyone with me there? So I'm looking for a box. Looking for a box, and that box is going to represent fixed cost, but it's going to have a height of average fixed cost and a length of Q. Everyone agree? So in our last minute, let's graph it. So marginal cost, average variable cost, average total cost. So I need all the curves. And let's put Q0. And do you agree we need to find average fixed cost? So to do that, I need average variable cost, and I need average total cost. All right, everybody with me so far? We know how to find those. So where's average fixed cost? In between the curves, right? This distance right here, which is also this distance right here. So we'd measure it dollar figure that way. So do you agree we have a height here of average fixed cost, and we have a length of Q? So this is our fixed cost box. You with me here? So guys, one last thing, because it will help with homework. Remember, just like on the charts, total cost equals fixed cost plus variable cost. So if you have total cost and you have variable cost, then do you have fixed cost on the graph? Yeah. Also remember, average total cost equals average fixed cost plus average variable cost. So again, these relationships apply to the graph as well. So use those to check your work. All right? Okay. If you have any questions, take a look at the video or email me.